All right, guys. Hey, jump to page 68, 69. Guys. You guys are gross. All right. 2006 AD number 5. Guys, at this point, I am just going through random problems. I'm going to do some of that today. I'm going to do some of that Monday. There's some stuff I'm skipping if you want to do it. I think the keys are on there. But you really ought to, at this point, start to feel pretty good about this. Like in BC Cal, they probably spend 7 days less than I do on this same material. So we are really doing lots and lots and lots of examples. Guys, take advantage of that, all right? All right, 2006. It says dy dx equals 1 plus y over x, where x can't be 0 on the axes provided. Sketch a slope field for the given differential equation at the 8 points. So they don't want to know. Notice, look, there's nothing along here. Don't come in here and sketch junk there, because if you're wrong, or if you do something that that reader doesn't like, then you get counted off. You want those 4 dots, those 4 dots. That's it. So starting at -2, 0, you need to make a little chart. Knock yourself out. Right? So at -2, 0, what's my slope? -1/2. So at -2, 0, I should be thinking down 1 over 2. I need to be pointing at that when I sketch my slope in there. Except obviously you don't want all this extra junk. What about at -1, 0? -1. So at -1, 0, I want to be going down 1. I'm still pointing at that same point. Make your slope reflect that. And -1, 1. -2. It's so easy to accidentally think -1/2. If you miss one of those points, you get 2 points for this, I think. And if you miss one, you just start losing your points, probably a half at a time. But I've not been a grader, so I don't know. What about -1? Sorry, -2. So -2 also pointing at that. Let's get that thing lined up. And then at -1, 0. So it turns out every single point was pointing at -1, 0. That's kind of interesting. Sorry?
That's a -1. It was I said -1.
It does on this one. But it also gives you some insight into the graph. If everything is pointing at this, what does it feel like? It kind of does feel like a problem for a moment. To me, it feels linear at this point, because no matter what thing I'm picking. Now, if I wanted to plug in something like -1/2, +1/2, just to kind of test that theory, but not mark the point, look what a -1/2, +1/2 does. -1/2 in there, +1/2 in there gives me 3 halves on the top. And what and then divided by 1/2 gives me what? -3. So couldn't I think down 1, 2, 3 over 1? It doesn't matter what units, right? I mean, I could also go down 3 over 1. But the point is, down 3 over 1, even if I'm going by halves, still is pointing me at that same graph, right? If every single thing points at that, I'm starting to think maybe this is like just a line heading towards -1. Until I got to recognize that what happens here? It's undefined, okay? And what happens if I'm sketching a slope field and it's undefined? What would I do when I hit that undefined spot? Put a hole and then stop. Don't keep going just because the other side might suggest it's going up. You would stop right there. Knowing that and recognizing that here is critical to another part of this question. And a lot of people miss it. Honestly, probably including myself. I mean, I looked back at this problem and I saw my work, but I don't remember if I missed it. Feels like something I might have forgotten to do. All right, so over here, or I might have done a little incorrectly, but you'll see that in a second. And I'm referring to this question right here. State the domain of the particular solution. So we'll get down to that in a second. What about on the other side at 1, 0? So I'm basically using these same, values, but now they're all positive. So at 2, 0, I'm getting what? Positive 1/2. At 1, 0, I'm getting positive 1. At 1, 1, I'm getting positive 2. So I'm really getting the exact same thing, but now they're positive values. So you can see at 2, 0, I'm still down 1, left 2, or up 1, right 2. I'm still heading towards that same point. Here, still heading towards that same point. Here, still heading towards that. Here, still heading towards that. So now what does this graph kind of resemble to you? If this one's heading to that, and that's heading to that, or this one's heading to that, and that's heading to that, what does it feel like? It feels like an absolute value problem. Right? I mean, I'm thinking it kind of feels like it's an absolute value of x problem, but it's shifted down what? Down 1, right? So it kind of seems like that, but the slopes might be different depending on which point I'm coming from, right? If I'm coming from up here, the slopes look like that might be 2. Right there, it looks like 1. Right there, it looks like 1/2. Here, the slope looks like 0. And if the slope is 0, it just gives me the graph y equals -1. And all that kind of makes sense to me. But honestly, if I was doing this problem in your seat, having only seen differential equations for a while, I probably wouldn't be overthinking this. I would probably be just sketching this. But remember that because I'm about to have to erase it to do the differential equation. Okay, so, well, maybe I'll just do it over here. So the differential equation now is asking me to do what? Find the particular solution to that. So if this is my differential equation, what do you do initially to start the process of solving? Separate. So the 1 plus y has got to get below the y. So I'm going to have to divide that by both sides. That's going to give me a dy over a 1 plus y. And then the dx, you're going to have to multiply both sides to get it on the right. But the x is now on the bottom. So when the 1 plus y left, that left an x on the bottom, and then you have the dx. And you're welcome to put the dx on the top, same difference. And over here, you're welcome to write this as 1 over 1 plus y dy. That's your call. So at this point, I'm all separated up. You got a point for that. You probably got 2 points for this right here. Usually it's like 3 and 6, but in this particular, I went back and looked. This was a 7 point you got for this. They got an extra point for this domain thing. All right, so when I integrate that, what do you have to do? Or is that a rule you know? It's a u sub, but you'll notice that when I do the u substitution, I don't know if anybody's picked up on this. If when I do the du, I end up getting dy, if you ever see du dy and nothing changes, it's not like du equals 3 dy or du equals -5x dy. If nothing changes, then you really don't have to do a u. You can just treat that like the u and go natural log. I mean, you can do the substitutions if you want. You get 1 over u. But I just go, oh, nothing really changes. So ln of the absolute value of 1 plus y, and here ln of the absolute value of x plus the c. Because I really didn't have to change that equation. And then from this point, still got to solve, right? By the way, you got a point for separating variables. You got a point for this part, a point for that part, and a point for the c based on the AP rubric, because I found the old rubric. So you're at 4 out of the 7 points right now. And then what? It says at the point -1, 1. Would it be a good time to plug in -1, 1? Just try it. What do you end up getting? The -1 in there for x gives you natural log of +1, which is 0. That works out great for me. But the 1 in there for y gives me natural log of 2. Do I really want to have a c value of natural log of 2? I'd almost rather e both sides, swing the c to the front, and then I'm betting I don't have an ugly looking c value. But again, you could do it. I'm not saying your answer would be bad, but it probably won't match the AP key. It'd probably still give you credit if you didn't mess up. But anyway, watch this. I'm just going to E both sides. Good question. Let's just work on the left side and then I'll answer that. The left side, I can clearly cancel the LNs, right? And that gives me absolute value of 1 plus y equals e to the ln absolute value of x plus c. Here, I can't I cancel that e and that ln x when there's something else added to it. I can't do it. But what can I do? Swing that c, and then once I swing that c around, then what can I do? Then I am allowed, because we have a rule that says a to the log a of blah, I can cancel, or e to the ln of blah, I can cancel. We don't have a rule that says e to the ln of blah plus something, I can cancel. So right here, it matches my rule, I can cancel. And what am I left with on the right side? C, absolute value of x, and absolute value of 1 plus y. And by the way, I'm doing part B if you haven't noticed this at this point. So all of this right here is part B. And then here, what would you do? This absolute value on the right, on the left side, all it does is put a plus or minus on the C, which is kind of consumed by the C. And at this point, I think it's a great time to plug in negative 1, 1. So at this point, I'm going to write, all right, negative 1, 1. And you know, I read back on the AP what they spit out, and it literally says 1 point for plugging in f negative 1 equals 1. It didn't say 1 point for plugging it into the right equation. So literally just acknowledging that is going in here and writing 1 plus 1 equals c absolute value of negative 1. And that obviously is a 1. And getting c equals 2. Just acknowledging that you're plugging it in gave you the point, whether you did it right or wrong. So they didn't give you a point for the correct c value. They give you a point for plugging that in to find the correct c value. So just doing that gives you an extra point. Now you're up to what, 3, 4, 5. Plug the 2 back in. Now, do I plug the 2 in here? No, you plug the 2 in right where you were solving. So if I plug the 2 back into that, I get 1 plus y equals 2. I'm going to write it over here. 1 plus y equals 2, absolute value of x. And what's the last step I make? Subtract that 1. Isn't that what I thought my slope field was? As I was thinking about it, absolute value. Now, why is it slope of 2 and not a slope of 1 or no slope? Because of the place I plugged it in, right? That was the specific solution at negative 1, 1, which was right here. So right there, that looked like this. Now, why is this wrong then? That's not the answer. And they even gave you a hint about it. So make sure you state the domain. What happens if you're sketching that starting at this point? What do you do when you hit the undefined? You stop it. And that's it. So if you're going to use that as your answer, well, there's nothing wrong with it. What do you have to put? You got to say comma or something, but the x value has to be what? Less than 0, which means any x's you plug in there got to be to the left of 0. I'm going to be honest with you, most people aren't getting that point because you just don't see weird junk like that. If you're looking at it going, oh, if they ask for the domain, that makes sense to me because I'm hitting undefined. Great. But again, you don't have to make 8s and 9s. If you make 6 out of 9 on every one of these or average that, you're looking at a 5. You might be looking at a little bit higher than a 5 because a lot of people do better on the free response. I mean, on multiple choice than do free response. My experience is most people who get 5s maybe do a little bit better on the free response because they really get it. You know, they're not just guessing so much, but it's usually, I'm not gonna say it's usually. On average, it's probably 50-50, but who knows? I've seen some of the most random scores. You'll probably take at least 3 full-length practice tests in here, not counting all the problems that we do that are actual problems that probably accumulate to more than that. But anyway, that's the solution. And they actually took this as well. they said, you're welcome to write negative 2x minus 1. Why do you think they take that? Because that is that line stopping it at 0. So either one of those they took, but this is the one you probably would come up with solving your system. You tracking? All right, that's form A. Let me talk to you real quickly about, they don't write form A on this. This is a 2006 AB number 5. If you miss that date, for whatever reason, got a soccer tournament, got a track tournament, anything like that, you get to take form B. This form B I didn't think was much worse, but a lot of times the form B questions, it's almost like they're just knocking a point off. They do something irritating or unusual that always causes a little bit lower score. I've had very few people miss my AP test. Maybe in all the years I've taught it, maybe 3 people, and one girl started throwing up right in the middle of the, she took the first 2 parts. I know, she took the first 2 parts and then got sick, and then the last 2 parts, I was like, dang it, she was gonna be one of my 5s, and she had to take it like 2 weeks later. But to her credit, still got a 5. And sorry I didn't give you much room. I mean, I squeezed it all in there, but I went and redid this thing, so next year, whatever, if whoever uses this again will be fine. I'd have to go look it up. It's normally like the 5th or the 6th, but every now and then they bump us to the 2nd week. I don't remember if this week they bumped us, or this year they bumped us or not.
I looked it up.
Is it first? I think it's usually the 2nd day.
I know this is my last exam, but early this is my last exam. I haven't seen
This one is, it might be 2nd week.
I think
then.
it's the 9th.
You find it?
Exams on the 2nd and the 4th of July, so if it's on the 2nd. Yeah, this one's on the 9th.
Yeah, Cal AB and B at 8 a.m.
Oh, yay.
So, yeah, so we're Monday. We are 2nd week. When's y'all's last day? Oh, but your last day in here is the 6th.
Oh, that's.
So that works out great for us. I mean, it's not necessarily awesome. It's not like everybody's going to get all these days, because a lot of you are going to miss exams. So we kind of sometimes have a kind of a shell of a class, but we will continue to review, and then we'll have it on Monday.
We're English. It's like, yay, last.
Y'all are English. I don't know. Are y'all lit or y'all comp? You're lit. So like, who's not in English, lit, and comp? Yeah. So I'll have 4 of y'all in here, right, in both classes. Chemistry. Who's in chem? Well, no, that's afternoon now.
Wait, that's us.
Um, geography, macro. Anybody in macro?
There are a lot of us. We have 2 exams.
See, like, so right there, I'll lose a ton of you. I'll let anybody. That's AP US. Euro? No, that's juniors. Yeah, so that Wednesday and Thursday, I'll lose a ton of you. But other than that, at least give us, it beats the heck out of that. Like physics 2, that stinks on Friday. I mean, you're gone from your teacher for a week. That usually takes a toll. Not always, but it does. But fortunately for us, we'll just have that weekend. Not bad.
It's like.
It's actually a win.
It's like, yay, last day of school, and then Monday you have to show.
Well, maybe more than Monday. But the good thing about it is there's not a lot of downtime, and we get the most review probably of anybody. Whereas people like this, you know, chemistry, they got 4 less days, 5 less days than I do. But yeah, I'll at least get you those 3 days. That's not bad. I think last year was the 6th or the 5th or something. But one year it was the 14th, and we were way removed from everybody from the last day of class.
Wait, so physics C has 2 tests. Is it like you choose one of those classes, or are they both?
No, E&M, one starts at 12, the other one goes to 2. So yeah, I don't think we do E&M, do we?
Yeah, we don't do.
We don't do E&M. We used to, and it's the long. I had to give that exam once, and you're here from like 12 to 4:30 or something. It's awful.
The one exam is also super long. It's like 4 hours. I remember
Just the C. I thought the C was just.
C is short.
Yeah.
But maybe the 1 is long.
Oh, is it?
It's like, yeah, so that's like 4 hours.
Yeah, some of them are longer than others. AP Cal's kind of long too, which is great because I'm not allowed to administer it. But the whole clock time, maybe 3 hours, 3.5 hours.
Well, that's not bad.
Yeah, some of them are. They
AP,
feel
Euro,
longer.
and US were 4.
Oh yeah, not that. All right, guys, let's look at form B.
I did take 0.
Guys, so you remember what we just did. Now, watch the math on form B. Now, the slope field's not a big deal, but oh, there was a trig problem in there. So all of a sudden, if you're a little shaky on the unit circle, you just got punched in the face because your slopes might be off. And then think about the integration of that. You're going to have to do U substitutions, all kinds of ugliness, just because you missed that day. So you really don't want to miss, if at all possible. Hopefully you won't have a conflict, but you never know. So sketching this right here, we only have 9 points. Well, we have 9 instead of 8, actually, so it's a little bit more. So we've got 9 points. I'm going to go quickly. So let's start with -1, 1. So if I put a -1 there and a 1 there, that's kind of nice because the 1 for y makes it all go away, right? Slope of 0. -1, 0. If I put a -1 and 0 there, I have -1 squared, which is 1. So all I end up with is the cosine of -pi. So if pi is that way, what's -pi? Around the bottom that way. So what's the cosine there? -1. Now, if you don't know that from the unit circle, you got to brush up on it or you're going to get smoked on this. You're going to lose at least 1 to 2 points on your AP test from missing all the stuff from not knowing unit circle values. All right. What about -1, -1? -1, -1. Well, now -1 minus 1 is -2 squared is 4. So you get a 4 from that, but you still get a cosine of -pi, which you just said was -1. So 4 times the -1 gives you -4. And that's a pretty big slope to have on a slope field. You don't see a lot of -4s. They usually try to cap it at -3 or so. But anyway, so me sketching these at -1, 1, I'm there at 0. At -1, 0, I'm at -1, which should point down here. And at -1, -1, I'm at -4. So -4 is kind of tricky. So how are you going to sketch a -4? I say instead of going up 4 over 1, what could I do? Up 2 over a half. So what if I went up 2 and just visualized a half would be about right there. So I'm visualizing that. Y'all with me? So, and then I get to the middle. So I've got 0, 1, 0, 0, 0, -1. So 0 in there gives me cosine of 0. What's cosine of 0? 1. So 1 times 1 in there gives me a 0. So it's all 0. And if I plug 0, 0 in there, again, 0 in there for x gives me cosine of 0, which is 1. 0 in there for y gives me -1 squared, which is 1. So I get a 1. And then 0, -1, again, 0 in there gives me 1. -1 in there gives me 4. So 1 times 4 is 4. So I ended up getting the same slopes again. So that part was similar about the other equation. But when I mark those at 0, 1, I have a slope of 0. 0, 0, I have a slope of 1. And at -1, sorry, at 0, -1, I have a slope of positive 4. So again, I'm thinking up to 2 over a half. So I'm kind of doing something like that. And then finally, at 1, 1, 1, 0, and 1, -1, what's happening? Well, cosine, if I plug a 1 in there, cosine of pi, same as cosine of -pi, right? All of those are going to give me -1 because I'm plugging in 1 for all 3 of those. So what happens when y is 1 times 0? When y is 0 times 1, which gives me a -1. And then finally, when y is -1 times 4, which gives me a -4 again. So I'm thinking, how do I go up there up to left 1, left a half? So they're kind of all over the place on this one, right? And I think if I remember the key right, they give you 1 point for getting all those right for one weird reason, for getting all the zeros accurate, which is probably the easiest part, and then 1 point for the other 6. Now, B. there is a horizontal line with an equation of y equals c that would satisfy this differential equation. Now, there's all kinds of general solutions to this, right? But they're telling you there's a horizontal line that could be drawn through here. Do you see it? What would it be? The equation would be y equals 1, right? So if it's the equation y equals c, and you know that that's y equals 1, then your c value would have to be equal to 1. You got a point for recognizing that. All right, last thing, find a particular solution at that initial condition. Now, I want you to see what happens when you show up and miss the AP test, because this is much uglier to me when you do the math. So separating the variables, I get dy over y minus 1 squared. And then you get dx pi x. Sorry, you get cosine pi x dx. So you got a point for that. And then you integrate. So is that a rule? So I don't recognize it. So what would you do? What are you going to make your u? Y minus 1? Y minus 1 squared? Because look, if you make u y minus 1 squared, then your du would be 2 y minus 1 to the first times 1 dy. And the problem is if you circle that for your u, you don't have any other y's left for my du, do I? So that didn't work. So what would be your second guess? Just y minus 1? So if my u is y minus 1, then my du would be what? 1 dy. So when I put that u in there, I get du on the top, u squared on the bottom. Now let's talk about the right-hand side. Is that a rule on your sheet? And some people go, yeah. No, it's not. It is if it's cosine x, but it's cosine of pi x. So what do you have to do? You already used u. You could use, most people use w for some reason, but you do some other letter substitution. So if I did a w substitution, I would say, well, what do you want w to be? Pi x. So if w is pi x, what's dw? Pi dx. Now I don't know whether they would count off or not if you used u. But technically, you're saying u, if you used u on the right, you're saying u is two different things. That's a little illegal in algebra. Okay? So dw would be pi dx, which means what do I need to make this work? Pi there, yeah, and a 1 over pi there. So there's my d dub, there's my dub, and I'd end up with this. Right? Cosine of w dw. Now, do I have a rule still for the left? Can I say natural log of u squared? But I can make it u to the negative 2, right? So if I made that u right there, just u to the negative 2, now I have a power rule.
No, it's a u squared.
So u squared.
I know, but like if your du is just dy, can't you do what you said? It's like
I can do what I said if that makes a rule. Like for instance, right there. Now, if you would have written that up top, like if you would have just recognized that this was this, right? If you would have recognized that and said, if I put a u, if I make u y minus 1, then du equals dy. Oh yeah, this is just u to the negative 2. So I could have just done that to the negative 1 over negative 1 and been happy, right? But I still have to move it and make sure it makes sense to me. So right here, what's u to the negative 2 give me? Power rule. So u to the negative 1 over a negative 1. And rather than write it over a negative 1, I'm just going to put the negative out to the side and plug my u back in there. And what is integral of cosine of w? Sine of w, right? The derivative of cosine of blah is negative sine, but the integral of cosine of blah is positive sign. So I'm going to drag down to 1 over pi sine of w and put the w to pi x back in there with a plus c.
You just flip them.
And then at this point, I personally don't like that negative. So I would probably multiply both sides by a negative and get to here. And yes, I probably would at this point. Once I once I got rid of my negatives by multiplying through by a negative, and you have to multiply the c by a negative, kind of eats it, right? Once I did that, I would do it. If you heard Sayla, she said, I would flip it. So I'm going to make this 1 over y minus 1 equals a negative 1 over pi sine of pi x plus c. And to me, it's as good as any time to find the c value. If I flip both sides right now, now my c is buried in the denominator. It's going to make it harder to solve for c. So I'm going to plug 1, 0 in right now. And my outcome ends up being negative 1 on the left, negative 1 over pi sine of pi times 1 plus c. Now, once again, what's sine at pi? Sine of pi. 0. Once again, I meant we're back at pi, not before we did cosine pi. But this time, sine of pi is 0. So all of that goes away, and I get a negative 1 for c. So back to here, back to 1 over y minus 1 equals negative 1 over pi sine of pi minus 1. So tell me, what would you do here to solve for y? Now, do we have a rule that says you can flip each part? Like, for instance, if I was adding 2 plus 3 equals 5, am I allowed to flip the 2, flip the 3, and flip the 5? Clearly, that is not true, right? 0.5 plus 0.3 is not 0.2. So this math is flawed if I try to do that. But I can do this back to the 2 plus 3 equals 5. I could say 1 over 2 plus 3 equals 1 over 5. That's still true, right? So I can flip this whole left side, and I can put all of that in a denominator. So negative 1 over pi sine of pi. Sorry, I forgot my x right here. Forgot the x. Minus 1. Put that whole thing under 1. And then the last step would just be add 1 to the other side. And I know that looks pretty ugly, but on a free response, you are not responsible for cleaning up your answers. Now, can I give you a little piece of advice, though? I'm going to erase all this. If this was a multiple choice question, which every now and then they'll ask you to solve a differential equation. If it was, and you had this as your answer, you're not going to see that as an option. So if you had this, what if this was option A? Would you think that you were right or wrong? Hold on, I'm going to really change it up for you. Would you be wrong or right in choosing A here? Is what I have there the same as that? Well, that's a +1. That part matches this, right? So I feel pretty good about that. What looks like happened here? I multiplied the top and the bottom by a pi. Oh, sorry, that's not right. This is right now. Sorry. I multiplied the top. Check it out. I multiplied the top by a pi and the bottom by a pi. That gave me pi on the top, and that gave me negative sine of pi x minus pi. And then what does it look like I do? If that canceled and gave me negative sine of pi x minus pi, what does it look like happened from there to there? I just moved the negative out. So it looks like everything's actually accounted for, doesn't it? Well, there was a plus. I'm just checking stuff off. There was a +1 there. There was a +1 there. I'm just kind of showing you that everything was accounted for. But it might look different than the way you have it. But on a free response, who cares? I would not do anything to this. I would leave it like that. And in some classes, like you go to college, they don't always make you solve for y. They do on the AP test. They didn't, ironically, back in the 90s. You were allowed to leave stuff sometimes like this. Because that is a differential, I mean, that is a solution. It's just not in function form. But in the advent of calculators and people being overly excessive about function form, they make you solve for y now. So you do need to do that. You just don't have to clean it up.
All right, let's take up a TI. Who votes TI?
And tonight, I'm going to have y'all generate slope fields with your calculator, 100 points.
I'll
You
take
might
that
change your
bet,
tune.
sir. My TI 84, my baby, she can take. Now I might take her. Well, but I will have a slow field for you in the morning.
Yeah, it doesn't have slope fields, but yeah, whatever. So 2001, number 6. Let's take a look. All right, the function f is differentiable for all real numbers. The 0.3, 1/4 is on the graph. So initially, this feels a lot different. So they're giving you a point on the graph of the solution, and the slope at each point is given by that. So now they're calling it a slope, but it's still a what? That is a what? A differential equation. So they're just calling it, oh, the slope is this. But of course, you should know that the slope is a derivative equation. That's a differential equation. Now they said to find what? That's the second derivative. So if I have the first derivative, let's see who remembers. I always get half of y'all or my students on this. If this is the first derivative, how do I take the second derivative?
Take the derivative.
I take the derivative of both sides. So I'm going to ddx the left, and I'm going to ddx the right. Now, when you ddx the left, what does it give you? That. Don't go low d high minus high d low over low squared. Literally, a ddx of a dy dx, that's why it's d squared y. Look, d, two d's, so d squared y, and you have dx squared. Remember we talked about that? They should write parentheses dx squared, but they don't. They're a little sloppy in math here. So don't go do any quotient rule, right? Just write that down. But here, what do I have to do to take the derivative of that? Product rule, right? First you say was 71st. So I'm going to work slowly with you, see if you're right. First, d second, -2 plus second, d first. Yes, not 2y, 2y dy dx, right? So 2y, and if you miss that, you're going to miss probably all of this right here. This is, I think, a 3-point problem for you. So 2y dy dx. Now, they want me to evaluate the second derivative at 3/1/4. So the second derivative at the 0.3, 1/4, and you have to label it, guys. This is the generic second derivative. This is the specific one. What am I going to do to find that second derivative? Tell me. Plug 3 in for all the x's and 1/4 in for the y's. But what are you plugging in for that? I either got to A, figure out that dy dx at 3/1/4, or instead of writing that, plug in what it is. So you could have just said times y squared 6 minus 2x. Which, by the way, had this not been a free response question, and they said, hey, what's the d squared y over the dx squared? Do you think you're going to see that? You might go, yes. No, you're going to see this. You're going to see the generic derivative as -2y squared plus what? 2y cubed. This is all multiplied together. Times what? 6 minus 2x squared. So if you want to simplify that first, it's going to be less plugging and shoving, but that's the second derivative if you simplify it. Are y'all seeing that? because this is all multiplication. There's a 2, there's a y cubed, and then there's 2 of these. And that's if I plug all that in for the dy dx. Which I gotta be honest with you, why write dy dx? You know you're gonna have to plug it back in there, so just take it and plug it in there, unless that's so brutal you don't want to. Or if there's a bunch of dy dx's in your problem and you're like, it's probably easier just to find the dy dx. But I will say this, if you are gonna find the dy dx at that, make sure that you're really clear when you write. Say, hey, the dy dx at 3/1/4 is what? 3 in there for x gives you what? Oh, nice. First derivative is 0. So if you want to do that, you can totally do that. And then you just enter a 0 in there. And what happens to this whole part? The whole right side of that thing gives me 0. But again, if you say right here, either way, when I find that derivative at 3/1/4, plugging that 3 right in here, all of that goes away. Don't cancel it out like I just did. But all of that goes away. And all you're left with is what? -2 times the 4th squared. So -2 times 1/16, -1/8. You got 2 points for finding the second derivative correctly on this, and you got 1 point for getting 1/8. So you're 3 points in on this problem. And it's a 9-point problem, at least in 2001. Then what do you got to do? Find y equals f of x by solving that differential equation with the initial condition. So they could have spelled that out more to you there, right? So once again, dy dx, y squared 6 minus 2x. So right there, let's separate the variables. dy, divide it by the y squared, and then multiply. I know that's a little ugly there. AP usually doesn't write it that way. I really don't know why I did. The dx comes up, it becomes a part of this. So what would be a good idea? You're about to integrate. What would be a good idea here? Can't go ln of y squared, can I? Yeah, go ahead and change that to y to the -2, and now you just have a power rule. Y to the -1 over -1, which is just negative that. And then 6x minus 2x squared over 2, so x squared plus a constant. What would you do at this point to solve for c? I normally do 2 things, but what would you do? You can plug in the point 3/1/4 right now, but when you do that, you're going to have 1/4 to the -1. You might be totally comfortable with that. I am. It's -4. But you might also want to go, some people go, you know what, I'm going to get rid of this front negative by changing all the signs over here. And then I'm just going to flip my y. And most people, I think, feel a little bit better about their problem like this. It's up to you. So now I'm plugging the point in. Plugging that in. Plugging a 1 divided by a 4th is a 4. 3 in there gives me a -18 plus a 9. And I get -9 on the right. When I add a 9, I get a 13 for C. So if 1 over y equals -6x plus x squared plus 13, then what's y equal? One over, and most people probably write it as x squared minus 6x plus 13. Right? You scribble a pi on there? What is that?
No.
TI-84.
TI-84. I'm gonna get it tattooed. I'm 18 now. I can get it.
I know somebody who does this.
Math
Like they would
tattoos.
give me a-
No, tattoos in general. We had a teacher named Justin Kennedy. He used to work here. He was a funny guy, a unique guy. But he loves some tattoos. He started getting them like, I think he was here like 6 or 7 years. And I first saw him, he had a little one right here. By the time he was done, he had this giant dragon that came around that side, came down this side. And he had all kinds of like Lord of the Rings symbols and math pies and all kinds of junk.
This guy, you know, hi, I chose your buddy. This guy, you know,
Lots of bad choices out there.
only
I've seen
does,
some pretty great, awful tattoos. When you start going down those bad tattoo rabbit holes.
Oh,
Oh
it's-
my gosh.
There's.
I don't know if I had time to do any more.
but entertaining.
I think I had in my notes to skip this anyway. Not that it was hard. I originally thought maybe we ran into something, but even this one, guys, check out. I'll just separate the variables for you. Hey, look right here, guys. If I slide, guys, if I slide the LNY up, I just want you to see it. What would you do? We've seen this before. Slide the LNY up or multiply to get to there. Multiply by the dx gives me negative xy dx. I would also have to divide by that y. How do you integrate the left side? Remember this? It's not a rule. But what could you make u that would work? If u is the natural log of y, what's the derivative of ln y? Y on the bottom, derivative of y on the top, dy. Do you see it? 1 over the y dy. So it really is a really clean u substitution, isn't it? And at this point, you're on your way. With the power rule or whatever. This one, the math gets a little ugly, but we're out of time anyway. So, guys, it's your call. If you're starting to feel really prepared and you didn't see anything strange about this, remember, there's a lot more than just this on this test. A lot of slow fields, a lot of other things. But you're not going to be reviewing. We will have the review on Tuesday as well.
So.